Okay, so today we are going to start with the next one topic, that is the covalent bonding. So move to the slide number 2. So first we are going to discuss about the formation of covalent bonds. Formation of covalent bond. And in this one way we would also define the covalent bond. So first if we talk about that how a covalent bond is formed, so it is said that when an orbital containing a single electron, or it can be called as an unpaired electron. Got it? Electron overlaps with an other orbital having unpaired electron. A covalent bond is formed. So Goodwill, can you tell me that from this one concept, what you have got about the covalent bond? What is the necessary condition for making a covalent bond?
It is that firstly, atom has to have an unpaired electron.
Yeah. So the first and
They
Hmm?
have to share a pair of electrons with another unpaired electron. They cannot be a electron that have a full shell.
Right. So there must be two atoms that are present with having unpaired electron in their orbital. It is the only condition in which a covalent bond can be formed, right? The next one thing, if we talk about the pair of electron that is involved in this one, you can say that state of affair. So the two electrons in the area of overlap. Goodwill, I am using E for the electron, right? In the area of overlap are called bonding electron, right? So these two electrons are basically referred to as the bonding electron. So whenever next time we refer toward the bonding electron, so it means that these are those electrons which are involved in the area of the overlap. So now we are going to define about a covalent bond. So if we talk about the covalent bond, so it is an electrostatic force of attraction electrostatic force of attraction between the two nuclei of atoms bonded atoms, and the other one thing is the bonding electron and pair of shared between them. So have you got the idea about the covalent bond?
Yes.
So simply it is said that if we talk about the covalent bond, so a covalent bond is basically formed between the two atoms by the sharing of electrons. So yes, there is a sharing of electron between the two atoms. And if we talk about that, what is actually a covalent bond? So covalent bond, just like we defined about the ionic bond. So ionic bond was said that it's an electrostatic force of attraction between the positive and the negative ions. But if we talk about the covalent bond, so it's an electrostatic force of attraction between the two nuclei and the bonding pair of electron, because you know that both the nuclei are having the positive charge and the electrons are getting the negative charge. So that's why there is again the electrostatic force of attraction, but now the attractive force is between the nuclei and the electrons. Got it? So move to the next one slide. Now we can talk about that how the overlap occurs, or what type of overlaps we can discuss for making a covalent bond. So it is said that there can be a large number of orbitals on the atom. So good girl, can you tell me that how many types of orbitals are possible in an atom?
Mm. So the type,
Yeah. So can you tell me the names of
it
orbitals?
is, yes, it will be the S orbital, the p orbital, the f orbital, and the d orbital.
Very good, excellent. So we can, if we write about the possible orbitals, so we can write about the S, we can write down about P, we can write about D and F. So all these four types of orbitals can be involved in the covalent bonding. But for the sake of simplicity, we are only going to discuss about the first two types of orbitals in this one level. Although the D and F are also involved in making the covalent bonds, but we are not going to discuss about that just for the sake of simplicity. So we can write down about the types of overlap and the manners in which the different orbitals would interact with each other. So we can talk about the overlap between the orbitals.
Okay.
So the first type of overlap we are going to discuss about is the S and S overlap. So it is the type of overlap in which the both concerning atoms are having s orbitals on them with the unpaired electrons. So that is the s and s overlap. So we can say that if we have the hydrogen atom, so in the center there is the nucleus of the hydrogen. And good girl, can you tell me that how many electrons are there on the hydrogen?
It is only one.
One. And in which one orbital the electrons of hydrogen are present?
In the s orbital.
Yeah, in the 1s, right? So we can
Yes.
represent the electrons of the hydrogen with the help of the cross, right? So this is one hydrogen atom. So if it would interact with another hydrogen that we are representing with the help of the red circle. So now we can represent the nucleus of the second hydrogen with the help of a purple dot. So we can see that if we want to represent the electrons of the hydrogen, another one hydrogen, so we can represent that with the help of a black dot, right? So this is again another hydrogen having one s orbital. So if the both hydrogens would interact in such a manner that they have an s and s overlap, so now we are going to show about the ss overlap in the case of two hydrogen atoms. Okay, so this is one hydrogen atom with its nucleus here, and the next one hydrogen atom that we can show with the help of the red circle. We are representing the nucleus with the purple dot. And if we want to show the electrons, so one electron can be shown with the help of cross, and the other one electron can be shown with the help of the dot. So good, this is the way in which two s orbitals interact. And if we talk about here, so we have got here the hydrogen molecule. So we have hydrogen that is bonded to the hydrogen. So this is the way in which two s orbitals can interact. Got it?
Yes.
Okay. So if we talk about that, where is actually the covalent bond existing? So basically you can see on the slide, we can write on the slide that there is an attractive force between this one nucleus and this one shared pair of electron, and in the same way this nucleus and the shared pair of electron. So this shared pair of electron is holding the two nuclei together, right? So that's why we can say that this shared pair of electron is responsible for keeping the two nuclei attached with each other. So this is actually the covalent bond. And you can see on the slide that there is a sharing of electrons between the two atoms. So that's why we can say that a covalent bond is formed by the sharing of electron. Got it? Okay, so now move to the next one slide. The next type of overlap we are going to discuss is the S and P overlap. So good girl, can you tell me that what is the shape of a p orbital?
Yes, it is the shape of a dumbbell.
Yeah, dumbbell. So first we are going to draw about one s orbital. So this is our one s. Suppose it's the hydrogen atom with its electron shown by the cross. And we have another atom. Suppose we have the chlorine. And you know that chlorine is having a p orbital on it. So we can say that we are going to draw about the another p orbital. Suppose we are going to draw a p orbital and you have told me the shape of p orbital. This is just like this one. So this is a p orbital. So it is also having the one electron in it. We can represent the electron with the help of a black dot. So when the two orbitals would interact with each other, so as a result there would be a bond between the two atoms. Suppose there is the red one with its nucleus in the center. The other one is this one. And we have the electrons of both the atoms, one represented with the help of the cross and the other represented with the help of a dot. So here the nucleus is present at this point. So in the case of a p orbital, the nucleus is present in the right in the center, right? So this is the overlap between the s and p. Just like this type of overlap and this type of bonding can be there in between the H and Cl, right? So the next one overlap can be between the p and p orbital. So we can draw two p orbitals. Here right in the center is the nucleus. Another p orbital. Both are having one electron, single electron in them. It is represented by a cross. The other one is represented by the dot. And when the two atoms would interact in such a manner that the two orbitals are overlapping end to end. So this is the manner in which the two orbitals can overlap. The other one orbital, here are present the nuclei, and in the center there is the position of electrons. So here it is represented by cross, and the other one is represented by the dot. So good girl, keep in mind that when the two p orbitals interact in this one manner, that one lobe of every p orbital is interacting with the other. So it is called as the end-on overlap. So this is an example of the end-on overlap. Got it? And when the two p orbitals would undergo the end-on overlap, it would lead to the formation of a sigma bond, right? So a sigma bond is formed between the two orbitals by end-on overlap. Got it? So now move to the next one slide. Now we can talk about the next type of overlap between the two p orbitals. So it is again the overlap between the two orbitals. So in order to differentiate the previous one, so move to the previous one slide. Now we can talk about the p and p overlap, but we would write along with it that p and p end-on overlap. And now move to the next one slide. Now we can differentiate this one overlap, that it's again the p and p overlap, sideways overlap. So if we are going to draw one p orbital in this one manner, and another p orbital, and both the p orbitals are containing again the single electron. Its electron is represented by the cross, and the its electron is represented by the dot. And when the two orbitals interact in such a manner that it is the sideways approach, I'm drawing the sideways approach on the slide. So this is an example of the sideways approach. We can make it more clear. So again, the two electrons would be present in the central portion of the overlapped region. So this is the sideways overlap, and as a result of the sideways overlap, a pi bond is formed. So from this one discussion we can conclude that there are two types of the covalent bond. The one is the sigma bond and the other one is the pi bond. And whenever the two p orbitals interact in end-on manner, so a sigma bond is formed, whereas when the two p orbitals interact in a manner that they are overlapping sideways, a pi orbital is a pi bond is formed. So, good girl, did you get the idea? Have you got the difference between the two types of orbital or the two types of overlap? Mariam, can you hear me? Okay, so now we can move to the next one point, that if we talk about the, so we can introduce the two types of bonds here. So types of covalent bonds. So types of covalent bond, there are two types. The first one is called as the sigma bond, that is represented by this one symbol, and the other one is the pi bond, that is represented by this symbol. Okay, so now we can move to the next one point. So next one point is we have to draw the dot cross diagrams for various simple types of the covalent compounds. So move to the next one slide. So we are going to draw the dot cross diagrams for various simple molecules. Drawing dot and cross diagrams. So basically a dot and cross diagram shows you the sharing of the electron between the two atoms. And when you are going to draw the dot and cross diagram, so keep in mind that you always include the valence electrons of the atom. The inner electrons of the atom are not involved in making the drawing the dot and cross diagram, because those electrons have nothing to do with the bonding between the two atoms. So just like we have drawn the diagram on the previous one slide when we discussed about the hydrogen molecule, so there was the dot and cross diagram for hydrogen molecule. So we can again draw the dot and cross diagram here on this one slide. So the first one molecule, the most simple molecule is the H2. It means that every hydrogen is having the two electron every hydrogen is having hydrogen molecule is having the two hydrogen atoms that are attached with each other. So you can also write down the electronic configuration of your bonded atoms that can help you to talk about the valence electrons. So every hydrogen is having atomic number 1 and its electronic configuration is 1s1. So it means that the two hydrogens are having their s orbital that would be interacting with each other. So here this type of diagram is for the hydrogen. So one circle because s orbitals are circular in shape. So we would write the hydrogen in the center. We have to show the overlap. So another hydrogen. So H in the center. And in order to show the sharing of electron between them, we can represent the electrons of one hydrogen with the cross and the other hydrogen with the dot. So this is the dot and cross diagram for the hydrogen. We can also draw the dot and cross diagram for various other molecules, just like if we talk about the dot and cross diagram for the chlorine molecule. So next one is the Cl2. So if we talk about the chlorine molecule, so it is having two chlorine atoms attached with each other. So first we have to write down the electronic configuration for the chlorine. So we can write the chlorine and its atomic number is 17. It means that the chlorine has 17 electron in it, and we can write down the subshell electronic configuration for the chlorine as 1s2, 2s2, 2p6, 3s2, and 3p5. So it means that the chlorine is having the 7 electrons in the valence shell because these two subshells are related to the valence shell. So we can draw a circle for the chlorine, this red circle for the chlorine. So keep in mind that when you're going to draw the dot and cross diagram, so no matter your atom is having the p orbital as the valence or subshell, or you can say that it is having any other orbital because the circle is representing the last electronic shell, not any type of the subshell. So it is the circle which is showing you the chlorine. So you can represent the electrons of the chlorine with the help of cross. So chlorine is having 7 electrons in the valence shell. So 1 electron here and the 7 others. Sorry, the 6 others. We would draw the second chlorine. This is the valence shell of the second chlorine. You can represent the electrons of the chlorine with the dot. So here it is a dot and the 6 more electrons. So this is how the dot and cross diagram for the chlorine molecule looks like. So we can draw about the number of the atoms, number of the molecules which are combining to give rise to the different type of covalent molecules and the covalent compounds. So move to the next one slide. We can even draw the few molecules which are having the multiple bonding means between that they are having the pi bonding between them. So if we talk about the oxygen atom, sorry, the oxygen molecule. So an oxygen molecule is having the two oxygen atoms attached with each other. So if we talk about the oxygen, so it is having the 8 atomic number. So 1s2, 2s2, and 2p4. So it means that it is having 6 electrons in the valence shell. This one, 2s and 2p. So we can draw the one oxygen atom. This is the valence shell of one oxygen atom. So this is 1O. And we can draw another oxygen. Now we can represent the electrons of one oxygen with the cross. So 1, 2 electrons here, 3, 4, 5, 6. Basically, how many bonds an atom would make depends upon the number of unpaired electrons. So if we talk about the oxygen, so oxygen is having two unpaired electrons. So that's why we can say that it would make a double bond with the other oxygen. So we can represent the two unpaired electrons in the overlap zone. So if we talk about the other one, oxygen, so its electrons are represented by the dot. So one dot and the second dot. 1, 2, 3, 4, and 5, 6. So this is the dot and cross diagram for an oxygen molecule. Got it? The next one example of the covalent molecule is the N2 molecule. So this molecule is having the two nitrogen atoms attached with each other. If we talk about the nitrogen, so it's having the atomic number of 7. So 1 is 2, 2 is 2, and 2p3. So the nitrogen atom is containing the 3 electrons, no, sorry, the 5 electrons in the valence shell. And if we represent the 5 electrons of the nitrogen, so it's this one is the valence shell. So it's a nitrogen atom. So it has its 5 electrons arranged in this one manner. A lone pair and then the 3 unpaired electrons. So as it is having the 3 unpaired electrons, So it means that one nitrogen atom can make the three bonds with other atoms. So that's why instead of showing them separately, because both the nitrogens can make three bonds with each other, we would represent them at one place. So we can draw the second nitrogen. So this is the second nitrogen atom. So the electrons of one nitrogen are represented by the cross. And the electrons of the second one nitrogen, they are represented by the dot. So this is the manner in which the two atoms are interacting. So both the atoms are having one lone pair of electron, and apart from that both atoms are sharing the three electrons. So there is the share of six electrons between both the atoms. So this is how we can show the dot and cross diagrams. We can show the multiple bondings with the help of the dot and cross diagrams. So all the electrons which are shown in the overlapping area, they are basically called as the bonding electrons. And those electrons which are shown outside the overlapping area, just like I can write on the slide. So if we talk about these six electrons in the center, so these are the bonding electrons. And as one bond contains the two electrons, so it means that there are three bonds present between the two nitrogen atoms. And if we talk about the electrons that are shown away from this one region, these and these one, so both of these can be called as the non-bonding electron. So with the help of dot and cross diagrams, we can represent the bonding electrons as well as the non-bonding electrons of one atom that is interacting with another atom to make a covalent bond. In the same way, if we talk about the oxygen molecule, so the oxygen molecule is having four electrons in the center and two electrons constitute one bond. So it means that there are four electrons, so there are two bonds present between the two oxygen atoms. So we can say that this is having the double bond between two oxygen atoms. And if we talk about the two pairs, so both these pairs are acting as the non-bonding or lone pairs of electrons.